So we were discussing different technologies, right? Uh, comparing different technologies. Solar energy is available only on sunny days and in the daytime. It is not available at night time. Wind energy may be available in the daytime or night time. It is not dependent on sun as such, right? But it may be available at day or night, or it may not be available. It depends upon the climatic conditions, right? The pressures available around the globe, or around that areas, right? So wind may blow or may not blow during day or night, right? So uh, wind energy is quite unpredictable. Solar energy is predictable but not continuous. Wind energy is not predictable and is not continuous. Wave energy is available day and night, right? It is continuous. Um, it may be very high. It may be more during some duration, some time of the season, or less, right? But waves are always there, either weak or strong, right? And once wave is produced, it stays there, right? It can travel thousands of kilometers once generated. Once a wave is generated, it can travel thousands of kilometers without dissipation of large energy, right? So energy is contained in the wave, right? It doesn't dissipate easily. इसमें अगर अपना काम करना है तो करके जाना है, ठीक है? अगर ये एक दफा प्रोड्यूस हो गई है, ठीक है? तो नॉर्मल सी वेव्स हर वक्त होती हैं समुद्र में. सो इट इज कंटिन्यूस, इट इज available 24 hours a day. Tidal energy, it is predictable, very predictable, and it is available um, intermittently, not continuous. We get 4 times a day this tidal energy. It is not continuous, but it is highly predictable. Tidal energy. Then there is what we have discussed, geothermal energy. Geothermal energy is continuously available, right? Um, if the source is there, it is continuously available. Um, it doesn't have any problem as far as availability is concerned. Hydel energy, it is continuous, it is available, but it may be seasonal. For example, we have water in Tarbela Dam in winter, in summer, but in winter, when the water level gets very low, when there is snowfall, and sun is not there, sunny days are not there, water is not melting, snow is not melting, the water level falls, right? And we have already made most of the water from the reservoir out for irrigation purposes or for producing electricity or both, right? So we may have shortage of electricity in the winter season if we are dependent on hydel energy, right? So uh, every energy source has its merits and on merits and demerits, advantages and disadvantages, right? So for wave energy, we have studied oscillating column and water capture system, two technologies at the moment, right? Oscillating water column, in which wave we have made a passage, closed passage, in which uh, wave may come. It is connected with water, right, from the bottom, always connected with water from the bottom, but it may be immersed to some depth in the sea, where there is water, but above it we have made it completely closed area, just a kamre ki tarah, theek hai? And we have made a small opening in it, right? So there is air over the water because air has to be there, right? But if water rises in that portion, the air will get out, right? So the when the air gets out from that passage, it will turn the turbine on. Similarly, when water goes down, the air has to come in from that passage because we have made only that passage for the air to come in. So water will come inside that space, right? So filling that space, it will turn the turbine on. So these are the two technologies. Third is very similar but immersed in the sea, which is a whale device, in which we have this space air chamber and then turbine here, right? So with the wave enter here, right? So water column is air column is there, air space is there. With high wave, it will move up, water level will move up, causing the air get out, and when water level is lowered, it will cause air come in. By the way, turbines are air turbines or air motors are designed in such a way that whatever direction air goes, it will turn in the same direction. The next technology is Pelemus. It is also called sea snake. The bodies you see here are not small; they are huge, huge bodies, right? Maybe 20-30 meters long, right? Uh, 20 feet, I think, right? So they are quite huge, uh, and these are huge structures which are placed in the sea. They are joined together through these linkages, and there is a mechanical system attached with it, right? So what happens is that these bodies with the wave move like this, right? So every two interconnecting bodies are moving like this, right? So what happens here is, if there are these two um, uh, these uh, uh, these arms, right? They are if they are moving like this will go inside it, and this will get out of it, right? And when it is there, it is getting out, and this is moving inside, right? So ये वाला पोर्शन जो सा है ये अंदर जा रहा है, ये बाहर आ रहा है, ठीक है? So there is cylinder, hydraulic cylinder here, hydraulic or pneumatic, um, in which this is moving and this is attached with a piston, right? So the piston is attached here with this arm, and when it pushes inside, the piston will push the fluid here uh, in this direction, and when it is pulled away, the piston is also pulled with it, and the hydraulic the fluid will move inside it, right? So there is movement of pistons, You can use cylinders or accumulators where the fluid may stay and under high pressure, and you can use that pressurized fluid to run the pneumatic or hydraulic motor. Motor means turbine, right? Sort of turbine. So that pneumatic or hydraulic motor or turbine will rotate with the under the pressure, and once that turbine is rotated, it will turn the shaft, and generator will be the shaft of the generator will be moved, and you will get electricity. So we see the video about it and you'll know. So this is the size of this one body, right? So these are the arms, right? And this is the cylinder assembly in which piston is moving, and these are huge arms, right? So they move. These are the cylinders where high pressure air or uh, fluid is stored, compressed, and then it causes the pneumatic or hydraulic motor to move, and that movement of motor causes the generator to work, and then electricity is produced. So you can see this joint structure, right, which is present, right? So so this arm may be called hydraulic ram. So this is reservoir, this is manifold, motor, this one high pressure accumulator, hydraulic rams, and heave. So this is how they look like and they work. The next is power buoy, right? In this buoy, this is the structure which is used to make it stable inside the sea, right? So it may be attached with the seabed at certain depths, right? So this may be about 30-meter deep, right? So this kind of structure. So what happens is that this is stationary part. The only part that moves with wave is this one. So it can move up and down, this portion, this one, and this is called buoy, right? Power buoy. So this is buoy which can move up and down in this direction, and here you can have different setups. One most easy setup can be that you attach a coil here, right? A coil, and fit the magnets with this one. What will happen is when magnets move near the coil like this, right? Coil is here, right? And magnet is moving around it, or here. What will happen is that this coil will experience the change in magnetic flux. Once magnetic flux is changed, EMF will be induced inside the coil. So electricity will be generated. That is one method. So one method is induction, in which a coil is there, magnets are attached with this, or you can say magnet is fixed here and coil is attached with this structure, this buoy, and this there is relative movement between coil and magnets, and that causes induction, or EMF induced is induced inside the coil, and you can get electricity through them. That is one method. The other can be that this buoy, movement of this buoy causes the hydraulic system, hydraulic and pneumatic system. It produces pressure inside the cylinders, and those cylinders are used, an accumulator is attached, and then that system is used to um run the motor, pneumatic or hydraulic motor, and which can turn the generators on. So these are and there can be this kind of arm, right? So these buoys move up and down, and this cause this structure to move like this, and this movement will cause the mechanism which will produce electricity in the same manner that either a fluid like water may be pushed through cylinders, and that water may turn the turbine on, and the turbine can turn the generator, and in this way electricity may be produced. So these are the buoys, right, for capturing wave energy. And you can use and you can devise different mechanisms. You can think of the mechanisms for wave energy by yourself, keeping in mind that the structure has to move like this with the wave, with the effect of wave following the crest or trough. Now, let's see. We have discussed the advantages and disadvantages of wave, right? There are no disadvantages, because they don't harm the environment. They are not directly interfering with the environment. We are not making dams or some big structures which may cause problem to the animal life, right, in the sea. Uh, no significant disadvantages. This technology is a bit, what we can say, that the materials have to be, we have to be strong in metallurgy. That materials used in these technologies have to bear the extreme environment of the sea, where they have to act with the water which is saltish, and which cause the highest cause sort of rust. So ships are there, and that kind of materials are available. So that is the um, that is how we can utilize wave energy, right? So let's see the different movies. uh, so this is the water oscillating water column technology. First of all, we see this. Wyeth is the technology, the company that develops this kind of technologies. This is famous for turbines and wind wave energy, right? So let's see what they have made here, and you can see how, because most of you live in Lahore or in Punjab, we don't have the sea around. Just see, just look at the the sea, how waves are there always and always, and always sea is busy. There is some movement every time. So you see the opening is here, right? But this is on the upper side, it is an enclosed chamber, right? An enclosed chamber, and that is the only opening for the air to get out or get in. So the turbines flow in the same direction, whether air is coming in or getting out. Either it is in this direction or in this direction. Blades are moving in same direction. So you can see power station here, the grids. Level of waves shown in this video we have in most of our coastal areas. Right? You can see this in Karachi and in the coastal areas of Pakistan or Gwadar. Now let's see the next technology. Uh, so this is Pelemus. Uh, these are huge waves, and you can see how the waves are traveling in this sea, right? Another thing is that they not only move up and down, they can move sideways as well, right? So in this direction as well. You see here? So these are high waves of 3 to 7 meters. You can see the rams or arms here. This one is pushed and this one is pulled. So three palamas are quite visible, and these are also called sea snakes. Sea snakes, Mundri Samp, right? Uh, so a number of palamas in deep sea with high waves, and you can see the waves. See how these waves get transmitted. So these are hydraulic rams, piston, piston here, and this is the fluid. Red color shows, I think this pink color shows pushing, and blue color shows pulling. And this is the pneumatic motor, right? This is accumulator. This is pressurized fluid. Motor is running, and this is accumulator, and from there it goes again pushed. So this is a circle is completed. See the size of wave, how huge and how big waves are, the wavelength, right? So let's see another video in which I think sizes are visible and how these are made. Palamas wave power by Siemens. See the rams and cylinder. Now you can imagine with the size of human being, which is 6 feet normally, you can just take it roughly as 6 feet and see the size of the diameter of these cylinders and the length of these cylinders, and imagine the size and the waves they were moving with this palamas, through these palamas. So they will push it with sea, with the ship. So in this power buoy, which is a bit submerged, there is movement like this for this buoy, and this is pushing a ram, which is in this cylinder, a piston, and that piston is pushing water, right, to high pressure, and that high pressure water is running the turbine. So you can use it for desalination as well. High pressure water is coming. So if you place here, uh, what we say, reverse osmosis, the filters, right, for osmosis in which you can osmosis is the process in which if you place saltish water and fresh water and separate them through a membrane, the water will flow towards saltish, right? So a pressure is generated, which is osmotic pressure. So you need, if you produce a filter for reverse osmosis, you have to get that pressure to let the water, fresh water, on one side and salt on the other side. Right? So we had discussed in our discussion over solar energy, right? Solar energy used for water desalination as well, in which we discussed Hitachi's technology for uh, Arab Emirates, right? In which they wanted to produce fresh water for animals in the deserts where the water is saltish, right? So you can use this pressure to for water desalination as well, right? It's not in the slides, but I have shown you here, right? And you should be able to write all this as you have seen in the um, in these clips, and you have to write it in your assignment for waves. In this assignment for waves, you have to write uh, what are waves, how these are produced, how winds produce waves, right? What are the potential areas, and what are the devices for this technology, okay? And how these devices work. So you will write in your own words, and that will prepare yourself for writing in exams as well. So buoy is called to that body which is floating in the water or sea, right? So these are buoys, right? So lever arms are there, which move with these buoys up and down motion, and then there is a mechanical system attached here for pressurizing the water. So Pelton turbine is there, right? High pressure water is coming through a small nozzle. In Pelton turbine, we had seen that it works with the high pressure or high head, right? And but flow rate is not that high. That's why Pakistan is not using these turbines. In Tarbela or Mangla, we use Francis turbines. So so be prepared for the what we say uh, quiz in the coming week. Right? It may be after 5, so that your classes is not are not disturbed. Quiz will be from